Hello, this is Mr. Stansbury. I'm going to take you through the 13D notes on depreciation. At the end of this, you should be able to say I can use the compound interest formula to calculate principal, depreciation rate, amount of interest, and or length of the loan. All right, so got a couple examples to take a look at, so let's do that. Captain America, this is example 26 from page 444, just in case. Captain America bought the new Super Duper Neato shield for $12,500. The shield depreciates by 15% per year. Find its value after 5 years, and then by how much did it depreciate. All right, so look at that. Captain America's got C-3PO, some duck in there, a minion, and oh, he's got a little crush on Wonder Woman apparently. So anyway, so let's take a look. Starting off with our formula that we've been using for all of these here. A equals P times 1 plus R over N to the N T. All right. Let's calculate how much this thing is worth after 5 years. So we're looking for the A. P is the original amount, which is 12,500. That's a 2. There we go. 1 plus the rate here, which is depreciating by 15. So let's put negative 0.15, because again, it's depreciating, divided by the number of times it's compounded per year, which is, if it's 15% per year, and depreciation is usually per year anyway. So anyway, we'll put 1 in there and find its value after 5 years. So we have a 1 times 5. So we're just going to go through and calculate that thing out. So really what this is A equals 12,500. This divide by 1 doesn't do anything, so we take 1 and subtract 0.015 and we get 0.85, all times the 5th power. Now, just to take note here, if you'll remember, when this number here is less than 1, that means the amount, it basically means it's depreciation. So that means every year it's worth 85% of the value it was the year before that. So that's what this means. All right. So let's plug this in and see what we get. All right. So we got 12,500 times 0.085 all to the 5th power. And we get let's see. I've got one too many zeros in there. It's like that is not. It's worth 6 cents. Yeah, that's not quite right. So let's do this. Second entry will get me my old entry back. I just need to delete this 0 in there. There we go. That's a little bit better. So it's now currently worth $5,546.32. 55.46.32. Okay, so Captain America's shield is worth a little bit less now. Okay, now they're asking by how much did it depreciate. So if it's worth this much after 5 years and it was worth 12,500 originally, all we need to do is simply take 12,500 and subtract $5,546.32 to see what we get. All right, so let's do that. 12500 subtract 5546.32, and we get 69.5368. 69.5368. So that's how much it depreciated. All right. So that's the first one. And let's try one more just for good measure here. Okay, this is example 27 from page 445. Giorgio buys a Panda for $15,000. 3 years later, he sells it for $95.40. Calculate the annual rate of depreciation of the Panda. So now we're going to go through and actually figure out what the depreciation rate of apparently owning a Panda is. So I think it would be very appropriate, since we're doing a problem about a panda, I should put a panda hat on instead of this hat. So I think that's a great idea. All right, let's start off with our favorite formula. A equals P times 1 plus R over N to the N T. You don't have to have this memorized, but hopefully we've used this so many times and this looks so familiar that you probably have it memorized by now. Okay? Because this is not actually an IB formula that's given to you, but it's certainly one that you could use if you're taking the IB test. So anyway, let's go through and figure this out. So it originally buys it for $15,000, so that's our P. 15,000, right? 3 years later, so that is going to be our times 3 here. 3 years later, he sells it for $95.40, so that's the amount after 3 years. So there's $95.40. Calculate the annual rate of depreciation of the Panda. So we are looking for that rate. And again, it's annual rate, so that means it's just one time. And again, depreciation is usually just calculated yearly. It's never, I don't ever remember a case where I've seen it calculated quarterly or monthly or anything like that. Okay, so we need to figure out what the R is here. So let's start peeling back the layers and figure it out. So first thing we want to do is get rid of this here. So we divide both sides by 15,000. And we will end up getting, let's see, 1 plus R. So we get 1 plus R all to the third power over here. And then let's see what we get on the other side. So 95.40 divided by 15,000. 0.636 equals that. Okay, so again, we're trying to get to R, so we got to get rid of that cube power there. So we got a cube root both sides. And that is not a 6, but a 0. And I don't know what that looks like now, but you know that that's a 0. So let's take the cube root of this 0.636 here. So let's do third root. And again, we can actually use this one originally because that's cube root. But I already put the 3 in there, so I'll just do this. Third root of, and I'm just going to do our answer. We get 0.85997. So let's just do 0. That's really close to 0.86. So 0.86 equals 1 plus R, right? Subtract the 1 from both sides. And we get that the R equals negative 0.14. All right? So that means, since it's negative, that's depreciation. So it's showing that it's depreciating by 14% per year. So the depreciation rate is 14% per year on average. All right? Okay. So now you should be able to say I can use the compound interest formula to calculate principal, depreciation rate, amount of interest, and or length of the loan. All right? If you have any questions, please ask. Thanks.